In this video, we have one identity to confirm or verify or establish, depending on what term you want to use. Now, as always on these, you start with one side, either the left or the right, and show the steps as to how you get to the other side. In other words, show that the left side is identical to the right side, or the right side is identical to the left. Doesn't matter which side you start with. Usually, you start with a more complex side. The left side has more terms involved. The right is just one. Now, if you have access or you covered other identities and you see something you can use, go ahead and do it. Use any kind of algebra, factoring, combining terms. But keep in mind, your objective is the right side. You want to transform the left side into the right side. Now, if you don't see right away how to proceed, can't figure out what to use, what identity to use, sometimes you can go ahead and convert everything to sine and cosine. So for this one here, got sine squared of theta, tangent of theta, sine theta over cosine. In the denominator, we have cosine squared. So again, this is a technique you want to use if you don't see right away what's going to work here. It's just converting everything to sine or cosine. Cotangent is cosine over sine. And then just simplify it and see what you get here. So in the numerator, we have a fraction sine over cosine. Denominator is cosine. In the denominator, we have cosine over sine. So I'm going to multiply the numerator and denominator by cosine theta times sine theta. So the numerator is multiplied by that product, and so is the denominator. So cosine theta over cosine theta. So all I'm doing is multiplying by 1, so it doesn't change it. Just writing in a different form. Notice here, sine theta, sine squared theta, that could be sine cubed theta, and cosine. So again, I'm just multiplying the numerator and denominator by cosine theta times sine theta. So the sine here and sine squared here gives me the sine cube, and then the cosine times that again gives me cosine. And then for the next one, none of the cosine I gotta cancel there. So I just get sine times sine. So this will be sine squared theta. In the denominator, I got a cosine squared, so I got a cosine cubed here, and a sine theta. This term here, cosine over sine, the sine cancels out, and I get minus cosine squared theta. Okay, so nothing simplified there. So now let's go ahead and do some factoring. We have a sine squared here and a sine cubed here. So that tells me I can take out a sine squared of theta. And then parentheses, took out the sine squared here, so that leaves me with a sine and a cosine. So this will be sine theta, cosine theta. And I'm left with one factor here of sine. Well, I'll take it back. I factored out the sine squared, so it leaves me with minus 1 here. So all we did again, multiply numerator and denominator by cosine times sine. So we got this step right here. And then from here, I took out a sine squared from the numerator. So in parentheses, what's left? Sine theta, cosine theta minus 1. In the denominator, see, I got a cosine cubed there for that factor here, cosine squared here, so I can take out a cosine squared. So let's see what we have left. Took out a cosine squared here, so it left me with cosine and sine. And I need a theta here. So I got cosine and sine left over. But that's the same thing as sine and cosine. So I'll just write it in that same order there. So this will be sine, theta, cosine, theta. And then I took out the cosine squared, left me with the minus 1. So you can see so far, we're just doing algebra here. Doing some factoring, some multiplication here. And now notice we have a sine theta, cosine theta minus 1, and a sine theta, cosine theta minus 1. So these divide out. Now you can write this now as sine theta over cosine theta. I'm getting my theta here. You can write this. Let me go up here and write it this way. Sine theta, cosine theta. And by this divided out, this is a 1, this is a 1. So all I have left is sine squared theta over cosine squared theta. Just to make sure, let me write it this way. And now we're going to use a basic fundamental trig identity. Sine of theta over cosine of theta, that's just your tangent. So this is equal to sine over cosine, that's one of your identities, tangent. Now I could put it in parentheses and then put the square, or I can just put the square right here. And that's what we wanted. Tangent squared theta. Mostly algebra, And then when we got to this point right here, we used a basic identity. It tells you that sine theta over cosine theta is tangent. Of course, we used it right here also. The identity for tangent is that, and of course for cotangent of theta, that's another basic identity right there. But anyway, this confirms it. You get to this point, and you just can say this is equal to this, tangent squared theta, and that's your proof. Thanks for watching. We'll see you next time.